Hello, welcome to the video. We're going to continue with the series. So I'm going to continue with the min-max. Okay. So we fill here we fill the move list. So now this is the start position. We're going to just find more legal moves. Okay, and then what it's going to do is next step it's going to do is going to loop through the moves. And then it's going to play each move and get the best score for each move. And it's going to do that. It's going to get the best score by calling itself. Okay? And to show you it, I'm going to do all the code. I'm going to step through the code so you can actually see it in action. Okay? So the first thing I'm going to do is I'm going to paste in the full function. Not everything, but I'll paste in most of it and then I'll talk about it. Alright, here it is. So now that move count represents all the legal moves. So what we're going to do is we're going to go, this is a for each loop, as you can see ends here. So it's going to go over each legal move. Okay, so what it is, so if there's 7 moves in it, it will start with the first one and it will set the first one to move. Okay, and then that's at this point it's going to do board move equals side. So this is where it makes a move on board. So it's going to actually make the move. Okay, so that means, say if it's at the top of the, say if this was the tree, I know it doesn't look like a tree, but say if that's the top of the tree, it's made the move now. So because it's made a move, the ply has to be increased. So it's made the move. It's made a move. So now it has to increase the ply on the board. Okay. So the ply is increased. The ply was 0. Now it's 1. And now what it does is it wants to find the score in that. So what it does, it's made a move. So the board has now changed here. So it's going to pass that change board in here. And the side has also changed. So what it's going to do is going to flip the side there. And it's going to, the depth was 7. Now the depth is going to be 6. So every time it calls itself, it reduces the depth. So now it's going to call itself. And eventually, the depth is going to be 5, 4, 3. Just like the other recursive function, it's going to keep calling itself. It's going to keep flipping. It's going to keep flipping these things. As you can see, whoever is winning, it's going to give a positive answer for that person. So if it's yellow's turn, it's going to give 100 as the scores. And if, just like the graph I showed you, because we're doing it this way, okay? And eventually it will come back with a score. After it gets the score, what will it do with the score? If score is more than best score equals score. So it will store, for the best score, it will store the best score and the best move. And after it does that, it will have to remove the move. So what it will do, it will take back the move. It will actually take the move back that it made. Well, that's what this is. I'll just call it take back move. And because it's taken the move back, it's going to set the ply back to, it's going to have to take the ply back because it's taken back a move. Imagine you're playing yourself at chess, and you play the first move, and now you want to play for your opponent, so you turn the board round, and then you play for your opponent, and then you turn it back, and now it's your move again. If you want to take back a move, you have to turn it back, and you have to take back your opponent's move first, and take the ply back. Or if you want to check a position that was 4 moves deep, you'd have to make a move. Your opponent makes a move, you make a move. So what this is doing, it's looking at both sides. So what it's doing is it's making a move and it looks at the best move the opponent can make. Then it makes another move, then it looks at the best move that it can make, and then it eventually reaches the depth, and then it gets all the scores, and then it does, and then that's how this works. Okay. So this is the part where it calls itself. So I'll put that just like the factorial thing we've done. That is actually going to call itself. However, I'm going to go into more detail of it, but before I do that, I'm just saying what it's doing. That fills the move. So that means say the ply is 0, the depth is 7, the ply is 0. What it first does is it fills the move list. So that means it says how much. So in this case, we've got 7. We've got 1, 2, 3, 4, 5, 6, 7 legal moves. So it would fill it with all of the moves. And it would. So what it would do, it would loop through all 7 moves, and on each one, this is what it will do. It will set move to the move. It would actually make the move on the board, which is here. It would increase the ply to ply +1, so it's made it the move, and now it wants to see what that move scores. So what it will do is, because it is yellow and it wants to see the score, it will have to flip it by putting minus there, and it flips the side. So it passes in the new board, it passes in the side. In fact, that's a global variable. It just passes a reference to it, so it doesn't really matter. It passes the side, and the depth gets decremented by 1. And then that is going to go off in its recursive way, and it's going to keep going further and further down in depth until eventually it will come back with the best score. Okay? And then it will check the best score, whether that is equal to the best, because it's going to check all 7 moves. So it will keep, if the best score is better than the best score so far, it will keep track of the best score and best move. And then when it makes, it's going to make 7 moves. After it makes the first one, here is where it takes it back. And then it goes back in the loop, it makes the second move. So for instance, it was going to make this move, see what the score is, take it back, then it's going to make this move, see what the score is, take it back, make this move, and then it's going to see what the best score is, and then it's going to return that best score here. And then by the time it finishes this, it would have had the best move. Okay? Now I just need to add a few things on here, and I'm going to add them now, and I'm going to talk about them. And this will complete the function. After I add these 2 things, we're going to be able to play a test game. Now, what if this move count is 0? That means there's no legal moves left. There's no moves left. There isn't any moves. There's no legal moves left. Okay, the board is full. So, if the move count is equal to 0, the best score is equal to that. Okay? So that's what we'll do. Whenever the move count is equal to 0, it will just go and do a check of the board and see what the best score is. Okay? And then the last part of it is this is where it's going to return something. Okay. If ply not equal to 0, return the best score, else return best move. So this is the part where I said that this minimax, which is here, let's just find it. Let's minimize that. Let's get computer move. It actually, as I said, it returns a move, not the score. However, for us to make it run recursively and run accurately, what we do is when the tree is here, the ply is 1. It's not 0. When it comes back to the top here, when it eventually comes back to the top, the ply is 0. So when it's done all the processing at the depth and it comes all the way back to the top and it gets the best score at the top, then we want it to return the best score. I mean, when the ply is 0, we want it to return the best score, best move. Otherwise, we just want it to return the best score. And then when it returns the best score, it will run itself. Now, what I'm going to do is I'm going to save this, and this should now work. So what I'm going to do is I'm going to play a test game, and we're going to observe something. And I'm able to beat it. It's going to run it to a depth of 7. So let me just check something. With this, we can put it in debug. It's better off if I do it in debug mode. So I'm going to do it in debug mode. And then what I'm going to do is I'm going to open the console, and then we're going to play it in the console. Okay, so what I'm going to do is I'm going to call main, and that will start the game. Now what I want to do, I want to exit it because I don't want it to cover the board. So what I'm going to do is, if I put it here, it shouldn't cover the board. So let's run it again. That's better. So it's going to say move from 1 to 7. Now, have you already done? Let me just check it. It should just stay in the loop. Invalid range. If I put 0, invalid range. So that's working. So now I'm going to make a move. Now, what it is, I want to win. So what I'm going to do is, I know for a fact that the center moves are better. So I'm going to move in the center, which is 4. And the computer, because of how it's searching, it's going to move. It's going to look at them. It's going to look at all the. It's going to look at all the evaluations, and it's going to think to itself, the first move is going to be the best move. So what it's going to do is going to move here because it can't see any difference. So what I'm going to do is I'm going to move. Okay, so I've made my move and it's made its move, and as you can see, I've moved there and the computer's made its move there, which is what I predicted. And as you can see, it's searched nearly 1 million positions, maximum depth of 7, and it's got the best move as 55, and it's got the best score as 0. So so therefore what it done is it looked at 55 because that was the best, because obviously when we are looking over the moves, we start from here. So therefore this is always the first legal move. So therefore when it finds that position for 55 is 0, that's the best move. And when it looks at all the other moves, none of them beat 0. So it would always play there, which means it's going to be easy to beat. So I'm going to play 4 again, and let's see what it does. Can you see it has played there again? So what I'm going to do now, I'm going to trick it. I'm going to play at 5, because if I play at 4 again, it's going to block it. But what I'm going to do is I'm going to play at 5 because I want to get a square here, and then once I get a square, you won't be able to win. So I'm going to play 5. here. And what it is, it's seen that within its horizon, it's seen that it's still got the best. Okay, you see, it's still got the best score of naught. Now, if I could have liked to win here. If I do here, it will win. But I'm not going to do that yet. I want to just check these numbers are correct because I know what these numbers should be. And these numbers actually do look correct. So it's working properly. Now what I can do now is I've got to go 1. I've got to go to 1. So I'm going to play at 1. Okay, I've got no choice. If I don't play at 1, I lose. So I'm going to play 1. Can you see? Now it's made its move, and it hasn't got. You think it would go here, but what it's calculated is, it's calculated that if it goes, it's calculated. You can see a win, because obviously you can see that. You can see that that column loses, so therefore it can see that it needs to go here. That's what so what it is, but it's still going to lose because I'm going to play 5. I'm going to play 5 now. So what it does, it plays there. Now it can't win. Even though it's got the score of 0, it can't win. Because what I'm going to do is, I'm going to play 6. He's got to go there. I'm going to play 6 again. Then he's got to go there. Then I'm going to play 4. And he's got no choice but to go here. Then I'm going to play 5. And he won't have any choice but to go here. Then I'm going to play 6. He won't have any choice to go here. And then by the time I play 6, I'm going to have 2 ways to win. So from here, he can't win. But what's interesting is, when does it notice that it can't win? When it notices that it can't win, it's going to do best score is 100. So let's carry on. So I'm going to do 6. And it's blocked it there. Can you see it blocked it there? 6 again. And it's blocked it again. Now at this point, I think that it's going to recognize that it can't win. So I'm going to press 4. I'm going to do 4 here. And that's the winning move. Now look at this, what it says. It's got, I press 4. And what it done is, it's got best score minus 100. And what it done is, it's done something that, if you're not familiar with AI programming, you think that it's made of a misprivate program. Probably, and what it did is, it didn't block that. It didn't block there, and it's going to allow me to win easily. So I'm going to press 4 now, and I win. But what it is, why didn't it block here? The reason it didn't block there is, it looked at the score, it looked at its best score, and it said, I can't win. The score is minus 100. So therefore, what it done is, it's thinking, that scores minus 100, so that's the best. That's minus 100, that's minus 100. All of them are minus 100. So what it done is, it played the first one. Okay? So what I did is, I can actually correct that. So what I'm going to do is, I'm going to add 1 line here to correct it. So what this would do is, what it would do is, it will return that the score will be different, as in, what we want the computer to fight to its last breath. We don't want it to say I've lost, I'm going to lose in 20 moves. So it's no use me blocking the 4 in the line. Okay? So what we want it to do, we want it to fight as long as possible. So what we're going to do is, I've done score minus apply. So that means that will skew the result. So what it would do is, if you can see that it can't win, it's going to say the ply is 0. So if I minus 0, that means that's going to give a score of 100. Whereas if the ply is 7 and it can't win, it's going to do 100 minus 7, and that's going to be 93. So if it's going to say that, I'm going to minimize that. I'd rather have a 93 than 100, so it's going to play 93, which will make it fight more. So what I'm going to do is I'm going to save this, and I'm going to play it again. Okay, so I just have to refresh this so that it picks up them changes. I'm going to do exactly the same moves again. For 5, 1, 5, 6. Can you see the scores are different? It's got best score -4, but that doesn't really matter. 6. Now the next move I move is going to be within its horizon, so it's going to see that it can't win, but it's going to start fighting. Instead of saying I can't win and lying down, it's going to fight till its last breath. All right, 4 now. And as you can see, it's got best score -97. However, it blocked it. Okay, so it's starting to fight now. So I'm going to play 5, and it's got best score -98. So it's still fighting. Now, when I play 6, I've got 2 ways to win. So to the computer now, I've got 2 ways to win. So if it blocks one way, I'm going to win the other way. So what it's going to say is, this move here is equal to that, because if it blocks one, I'm going to win. If it plays here, I'm going to win the next move. So what it's going to do, it's going to play here. So I'm going to play 6, and then it's just going to, it should block the 4 in the line, but it's not going to do it. But I'm going to leave it doing that. I'm not going to bother with that, because I have to put a lot of algorithms in to stop it doing that. I'd have to put, when ply equals 1, I'd have to put something to check to block a 4. And to be honest, it's only when the ply is equal to 0 it will do this behavior. So I will just have to put some code in, but I'm not going to do it. So I'm going to play 6, and it put its thing here because it knows that it can't win, and the score for there is equal to the score here. So I'm going to put one in 7 and win. 7 wins. Now I'm going to play another game. I'm going to make it win. I'm going to make the computer win on purpose. I just need to check that it can win. So now I'm going to play 5 again, and then it's just going to win. And there you go. Computer wins. So that's it. The AI part of the game seems to be working. But what I'm going to do is, this video's been running long. So what I'm going to do is I'm going to stop this video. I'm going to continue another video. Now, what I'm going to do on the video is, I'm going to go through the min-max in more detail, because now I've got it coded up. I can actually step through the code. It's hard to explain it sometimes. It's easier for me to step through the code in the console and talk about it then, rather than. So what I'm going to do is, on the next video, I'm going to set it up just so I can explain this, and then once that is done, then this part is going to be complete, and the next, well, it's not going to be, well, it's going to be complete until I finish the GUI. So I'm just going to, the next video, I'm going to explain min-max more, and then I'm going to change the code, but I'm not going to do it's not going to be in a video. I'm just going to change it. I'm going to change it offline because I want what this is. This is the AI code, and then you're going to have the code for the graphics. So I want to merge them together, and in this form, you couldn't merge them together. So what I want to do is it's going to be exactly the same code, but it's going to be in a different form. But I'm not going to do a video about it. I'm just going to do it offline because it's not relevant to this. But anyway, thanks for watching. Until next time, bye.